Hey guys, talking with second period today and Mr. Williams, we were talking about an easier way to look at these to see if they're linear or not, rather than having to write out the y2 minus y1 over x2 minus x1, which still works. But just to kind of simplify it for some, which we worked on those that were in class today, we worked on it some more. So what we would do is looking at this random one I picked up right here, I would see how far is it going from this y1, let's say, to y2, and then we'll see how far does it go from y2 to y3. And by how far I go, I mean, is it adding or subtracting, and by how much? So the first one I went from 19 to 13, so it's getting smaller, so I'm going to write subtract. And it's 19 minus 13 is 6, so it went down 6. Then I went from 13 to 7, so it went down again, so subtract. And 13 minus 7 is also 6. So not important as far as the answer yet to, hey, they're the same. Like, that doesn't matter right now in that aspect. What matters is we now need to look at the other side, and we're saying I went from x1 to x2, and it got bigger, so that means they added, and it got bigger by 1. 13 plus 1 is 14. Then to go from x2 to x3, it went from 14 to 15, so it got 1 bigger again. Okay, so the last thing you would look at then is these numbers right here and these numbers right here. So what I have is, let me switch to pen. I have, this is my rise and this is my run, remember, X and Y. So -6 is my top number for the first one, and then my bottom number would be 1. -6 is my top number for the second one, and 1 is my top number. Now, if they're the same, whoa, that looks like the Avengers. If they're the same, which they are, then it is linear. If these happen to have been different, then they're not linear. Something you're going to want to be aware of, if you have your calculator, it can do this for you. If this would have been reducible, I probably would have wanted to see what it reduces to, because if it reduces, if this would have been -12 over 2 instead of this, that reduces to that. So yes, they are still the same. So just be aware. Remember, if you have your calculator that the school gave you, you can just type in 12, then press the negative button. I'll write down here. The negative button looks like that, remember? And then divided by 2. Actually, wait, instead of writing divided by, there's my mistake. First one all year right there. First mistake. You type that A, B, C button on your calculator. Now, if you do that, if you type this in right here, oh my gosh, it's going crazy today. If you type -12, remember you got to type 12 first and then the negative button, ABC, 2, and then press equals, it'll reduce it for you. And it should say something like -6, like this little L and then 1. This just means -6 over, I don't know why they give you that symbol, but that means over 1. So that's the same as -6 over 1, okay? Let me do one more quick problem now that I've showed you that. Go jump one, see if I get another one rather than a graph. Yeah, I don't want a graph. Those are easy. Okay, this is literally the same problem. Quit giving me the same problem, Becky. No, I'm making the video right now, honey. Say hi.
Hi.
That's my math expert helping me out. Okay, if you get too far, they get into fractions, which somebody in class today did do that, and he powered through and got to 100, so props to him. He might not be the only one, I'm just saying. I watched him. And then, come on, IXL, give me one more that's not the exact same one. All right, I said they were linear. Give me another one. There we go. Okay, so if I do the same thing. This one went down 5, so -5. This one went down 10. So some of you might say, oh, they're not the same. The answer is no. Wait, it could be reducible and stuff, so we still got to do the same thing. This one went up 1. This one went up 1. So the slope for the first part was -5 over 1. The slope for the second part is -10 over 1. Now, neither of these are reducible, so it is non-linear. And the reason why, just to kind of show you guys real quick, is if I had to graph this, it'd be like saying my first dot was at 717. 717, let's just say it's right there. The second dot was at 812, so let's just say it's right there. The next dot is at 9-2. And what you can see kind of happens there is, yes, I'm making straight little marks here as I go, but I mean, it's not exact. You can see all of a sudden the slope changes. It was going down, but now it's going down a lot faster. So this slope is a lot steeper. So that's why it's non-linear. It has somewhere the slope changes. Okay. Hopefully that helps, guys. Say bye, Romy.